this video, we're going to talk about the product and quotient rules. We'll state the theorems and then, or the rules, and then we'll work some problems. For both product and quotient rules, we start off with this. If f of x and g of x are both differentiable, remember, not all functions are differentiable everywhere. But when we say they're differentiable, we mean everywhere on the domain described. If you don't have a domain, then it means everywhere. Okay. Then the following is true. Theorem 1, the product rule. Now, this is another command to take the derivative, d over dx. If you take the derivative of f of x times g of x, this is clearly a product, so I'm about to write down the product rule. What you get is the following. You get f of x, g of x, plus f of x, g of x, almost. First, you take the derivative of f and not g, and then you take the derivative of g but not f. And the other theorem, the quotient rule, is very similar. You have f of x over g of x. The derivative of that, well, it's just like the numerator with one minor exception. It's just like the numerator, except it's minus, and you divide by the denominator squared. It's the way it is, folks. That is the product and the quotient rule. So, sometimes you take the derivative of f, sometimes you don't take the derivative of g, sometimes you don't take the derivative of f, sometimes you do take the derivative of g. And in the first case, I meant to say you do take the derivative of f. Okay? So, let us work some problems. Suppose that f of x was equal to 3x squared minus 5 times 2x minus 8. Now, of course, you can multiply this out and then take the derivative, but let's practice the product rule. The first function will be f of x, and the second one will be g of x. That way it matches our formula. So, now whether you write down what I'm about to write down or not, you at least have to think this. We take the derivative first, we take the derivative second there. So even if you just say it's the derivative of the first, which is 6x, well, that's what I get when I take the derivative of that. It's the derivative of the first times the second function plus the first, don't change it, times the derivative of the second, which is 2. Now, so the calculus is done. I took the derivative of a polynomial. I didn't take the derivative of a polynomial. Again, I didn't take the derivative of a polynomial, and then I did. That's the calculus. Now algebra, distributing the 6x. You get 12x squared minus 48x. Distributing the 2, you get 6x squared minus 10. 12x squares plus 6x squares, that's 18x squared. Minus 48x minus 10. That's the derivative. And we used what's called the product rule. Let's try another one. Suppose you were told that h of x is 7x to the fourth minus 2x plus 1, and this is being multiplied by 3x cubed minus 4x plus 5. That's the first function. That's the second function. The derivative says take the derivative of the first function, which is 4 times 7, make the new power 1 less, minus the derivative of a constant times x is the constant, and the derivative of a constant like 1 is 0. That's the derivative of the first times the second, plus the first. Don't take the derivative of it, times the derivative of the second. The derivative of 3x cubed, you multiply the two 3's, you get 9x to the second, minus the derivative of a constant times x is the constant, plus the derivative of a constant, which is 0. The calculus part is done. I took the derivative of a polynomial here and here, and here I didn't. Now algebra, FOIL it out. You get 84x to the 6 minus 112x to the 4th plus 140x cubed. Now distribute the 2. Negative 6x cubed, 6x cubed plus 8x minus 10. Due to lack of space, I'll put it on the second line, and I'll even line up stuff. 63x to the 6 minus 28x to the 4th minus 18x cubed, minus plus 8x, Now I distribute the 1, and 1 times this is just going to be that, 9x squared. I'll add them here because there are no x squares, plus 9x squared minus 4. And the final answer will be 147x to the 6 minus 140x to the 4th plus our 122x cubed. Now I have a concern here because I see that I have 2x cubes. Did I mess up? I'm going to check, please. Okay, no, I didn't. So I also, from the 122, I have to take away 6 more x cubes. Sounds like 116 x cubes. Then I'll say the 9x squared plus 16 x's minus 14. Minus some silly arithmetic error. There is your answer. Okay, let us try another one. Just keep doing these. Now, suppose that h of x is 7 times 3x cubed plus x. Now, we have a rule that says that the derivative, d over dx, the derivative of a constant times f of x is the constant times the derivative of f of x. Also can be written as this. So, h prime of x is just the constant times that derivative, which is 9x squared plus, that's 1x. The derivative of a constant times x is the constant. There it is. Now, just want to show you something. Let's call it j of x. if j of x is a constant times a function. Let us use the product rule. This is the first function, that's the second. It's the derivative of the first function times the second plus the first function times the derivative of the second. 0 times f of x is 0 plus k times f of x. And 0 plus this is this. Okay, that is to take the derivative of this. It's k times the derivative of f. There's no, and that's what we did. We kept k and then we multiplied it by the derivative of this function, 9x squared plus 1. Do not use the product rule if one of these two is a constant. Do not use the product rule if one of those two is a constant. Let's look at the next problem. You always want to try to get out of using the product rule like we did in the last problem. And you should also try to get out of using the quotient rule when you can. Now, whether you write the next step or not, this is 3x cubed over x minus 2x squared over x plus 5 over x. Well, that, whether you look at it over here or over here, that is, no, I want to change this to 5x. So this first fraction is 3x squared minus the next fraction is 2x plus the next fraction is 5. Oh, I can find the derivative of that. Bring down the power, make the new power 1 less, minus the derivative of a constant times x is the constant. Plus the derivative of constant is 0. There's your answer. And that 1 you don't need to put. You didn't have to use the quotient rule. We just did the division first. Now, suppose you have this problem. Suppose you have f of x is equal to 3x cubed minus 2x squared plus 5x, same as the last numerator, but now we're dividing by x minus 1. Now, if you want, you can actually do the division. You can do x minus 1 into this. Maybe it'll work out to be something nice. Or maybe not. But I think that it would not be time well spent every time. That is, I would use the quotient rule here. It's the derivative of the top, which we did. No, we didn't do. So, it's going to be 9x squared minus 4x to the 1 plus a constant times x. The derivative is the constant. That's the derivative of the top times the bottom. Minus. This time, you keep the top the same, 5x, and you multiply it by the derivative of the bottom. Well, remember, that's 1x. So the derivative of 1x is 1 minus the derivative of 1 is 0. So 1 minus 0 is just 1. All over, don't forget, the denominator squared. So you distribute. You get 9x cubed minus 9x squared. And then you get minus 4x squared plus 4x. And now distribute the 5. Get 5x minus 1. All minus this times 1, which is just this. Minus 3x cubed minus 2x squared plus 5x. And all of this is over x minus 1 squared. Okay. So now let's see what we can do with the numerators. We have 9x cubed, and you're taking away 3x cubed. I guess you have 6x cubes. You take away 9x squares, and then you take away 4 more x squares. You took away 13x squares. Took away 13. And now you're taking away negative 2. So that's negative 11 x squares. You have 4 x's and you add 5 x's, that's 9 x's, and you are taking away 5 x's, that leaves you with 4x. Don't forget the minus 1. All of this is over x minus 1 squared, and that is your derivative. How about we try a few more? Suppose you have f of x, and it is equal to 4x to the 5th minus 2x squared plus 11 over 5. You do not want to use the quotient rule, because if you take the derivative of g of x over a constant using the quotient rule, well, it's the derivative of the top times the bottom minus the top times the derivative of the bottom, which is 0, all over the bottom squared. Well, this is 0. So you get g prime of x times k over k squared. But I can kill off a k on the top and a k on the bottom. Oh, you mean I could have just taken the derivative of the top and divided by the k? Yes, because that's a constant. This is the same as 1/5 times 4x to the 5th minus 2x squared plus 11. We can use the constant multiple rule. So the 5 just stays there. 4 times 5 is 20. Make the power 1 less. 2 times 2 is 4. Make the power 1 less, which you don't have to put when it's a 1. And the derivative of a constant is 0. There is your answer. If you like, you can factor out a 4x, and you'll have 5x cubed minus 1 all over 5. I like answers in factored form, so I would really expect this. This 20x to the 4th, this is the same as 4 times 5 times x cubed. And the right side is just 4 times x. Well, we had the 4 and the x, that's why I factored it out. And what survived was 5x cubed minus 1. Think about the minus 1. Suppose now that f of x was 3x minus 4x to the 5th minus 11. And this is all over x cubed minus 2. This is going to involve the quotient rule. But it's not hard because we're just taking derivatives of polynomials. The derivative of the top, well, the derivative of a constant times x is the constant, minus 20x to the 4th minus 0. The derivative of 11 is 0. That's the derivative of the top times the bottom minus. Now we reverse it. We just keep the top the way it is, and we take the derivative of the bottom, which is 3x squared. The derivative of 2 is 0. And all of this gets divided by the denominator squared. Do not FOIL out the denominator. because we like answers in factored form. Okay, distribute this 3. You get 3x cubed minus 6. Distribute the 20x to the 4th. You get minus 20x to the 7th plus 40x to the 4th. Minus, distribute the 3x squared. You get 9x cubed minus 12x to the 7th minus 33x squared. And all of this gets divided by x cubed minus 2 squared. So we have 3x cubed, and we are taking away 9x cubed. We have negative 6x cubed. We just have minus 6, and that's it. Then you have negative 20x to the 7th, so negative 20, minus negative 12. That's our negative 8. Negative 8x to the 7th. And you have 40x to the 4th. And lastly, you have to take away negative 33x squares. And this all gets divided by x cubed minus 2 squared. Good luck factoring the numerator. Leave the answer like this. Okay, let us finish up this section with this problem. Suppose you have f of x is equal to 3x minus 5 times 1 over 7x plus 4. Now you can use the product rule where it's this times the fraction. But let's multiply. Multiply the two numerators. You get 3x minus 5. And if you like to have a 1 there, multiply it, or just write 7x plus 4. I look to see if there's a quick way of dividing them. I don't see it. So then I use the quotient rule. The derivative of the top, well, this is a line. mx plus b. The derivative of the top is 3 times the bottom minus the top times the derivative of the bottom, which is also a line. So the slope, m, that's the derivative. All over the bottom squared. All we did was take the derivative of polynomials, simple polynomials, lines. Okay, the denominator we know. Distribute this 3. You get 21x plus 12 minus, distribute the 7. You get 21x minus 35. The 21x's cancel. 12 minus negative 35 is 47 over 7x plus 4 quantity squared. Just take the derivatives of polynomials at the right time. The hard part is the algebra. I would hope that this part was just memorizing a formula and taking the derivative of 3x minus 5, which is 3, taking the derivative of 7x plus 4. So it's the derivative of the top times the bottom minus the top times the derivative of the bottom. All over the denominator squared. Now, just to point out something, the reason we don't FOIL out the bottom is let's make believe that the top turned out to be, I don't know, 3 times 7x plus 4. And then when you divide it by 7x plus 4 squared, you can see the 7x plus 4 canceling. I cancel out 1 from the top, leaving just none, just the 3. And I cancel out 1 of the 2 in the bottom, leaving 1 left. Good luck if you had 3 times 7x plus 4 over that bottom squared. If I FOILed it out, 49x squared plus 56x plus 16. You would never ever see that this over that just becomes 7x plus 4 on the bottom. Don't FOIL out. Now you may say, all right, I won't FOIL out, but how come you're FOILing out here? That's because what's in blue are not factors. They're being subtracted. I am hoping that once I FOIL them out and I do my subtraction, and if I did get this, I'll say, oh, these have like factors. Okay, so you have to factor out. You have to distribute first. Of course, one last comment. If this numerator would have been, instead of 3, if it were 3x minus 5 times 7x plus 4 minus 3x minus 5 times 7, you better believe that I would have factored out what was coming. 3x minus 5 times 7x plus 4 minus the 7. I definitely would have done that. But this wasn't the case. And let's see, this isn't really here, and this isn't really here. The final answer, minus some silly arithmetic error, is that. Okay, no calculus errors. I know that the derivative of this is 3, and the derivative of that is 7. I know that. The derivative of the top, yeah, that's 3, times the bottom, yep, the bottom is 7x minus 4, minus the top, yep, that's right, times the derivative of the bottom, yeah, it's 7, all over the bottom squared. All you do so far in this course is take derivatives of polynomials, which is simple. Just learn where to put them. The algebra is the hard part in Calc 1. The calculus is not hard at all. See you guys in the next video.